Okay, so today we will learn coupon bond stripping. In the last class, in the film learning, I think you learn how to price zero coupon bond. So we already know how to price zero coupon bond, right? Yes, zero coupon bonds. Okay, zero coupon bonds. So for example, fixed income contract that pays you $1 T years later is valued as, okay, I'll use latex. Okay, so V, okay, let's say it is the what kind of notation? What notation? Okay, okay, let's say Z because it is zero coupon bond. So Z, 0 T, let's use big T, small t. Let's use small t. T years later is GT equals basically $1 multiplied by, and then E to the power of minus RT. It is called latex. It is very good to write scientific writing. So looks like this one, right? You know this one, right? And then we can also compute the value of coupon bearing bond, which has multiple cash flows. We can also compute the value of coupon bearing bonds. Now, for zero coupon bond, the cash flow occurs only one time, right? Only once. But for coupon bearing bond, there are many cashes. And then we know how to do that by decomposing coupon bearing bond into series of zero coupon bond, right? By decomposing the coupon bearing bond into a series of zero coupon bond, right? A series of zero coupon bond, right? So, like, suppose there is a bond, zero coupon bond, valued at time zero is therefore it is basically some 0 to the power of t of basically cash flow t equal 1 to the power of t, and then we have a series of cash flow at time t, and we have to discount it, right? With this one, zero coupon bond price, since we know the formula. Okay. And then we run the equation. All right, we know we can calculate, right? So we have a cash flow, CF amount cash flow at some time small t. So basically we are decomposing a coupon bearing bond into the series of zero coupon bond, right? So per dollar value is like this, G. So for CFT amount, we have to multiply CFT because of per dollar amount. Z is per dollar value, and then so we can series of it. But then in reality, zero coupon bonds are not actively traded. Coupon bearing bonds are more popular and therefore liquid, right? Therefore more liquid, okay? Therefore more liquid, okay? So hence, okay, hence we need to find zero coupon bond. We need to find the value of zero coupon bond out of coupon bearing bonds, not the other ways around. Okay. So you know what I'm saying, right? In theoretically, we know how to calculate zero coupon bond, and for coupon bearing bond, it is a series of zero coupon bond. So we can just like Lego block, combining Lego block. Okay, we can combine zero coupon bond to calculate coupon bearing bond price. But in reality, zero coupon bonds are not that actively traded. The liquidity is far lower than coupon bearing bond. So in reality, what we have to do is first, we have to calculate. First, we collect data for coupon bearing bond. And then from the coupon bearing bond data, we estimate, we find, okay? Basically, we estimate the value of zero coupon bonds. Okay, so the other letter. So anyway, once we extract the price of zero coupon bond from coupon bearing bond, once we do that, now we can combine the estimated zero coupon bond price to price other coupon bearing bond. After we identify after we estimate the value of zero coupon bonds, we can combine them to compute the value of other coupon bearing bonds. Okay, so that's the point. So you know what I'm saying, right? Then the question is how to obtain. Now the question is how to obtain zero coupon bond prices implicit in observed coupon bond prices, right? Again, coupon bearing bonds are widely traded and therefore usually provide the best source of data for the determination of the underlying zero coupon bond price. So the procedure for inferring the underlying zero coupon bond price is called coupon bond stripping. Okay, coupon bond stripping. So coupon bond splitting means the procedure to infer the zero coupon bond price out of coupon bearing bond. So let me show you how to do it. So suppose we have a collection of coupon bond prices. So suppose we have n number, small n number of coupon bearing bonds. Okay, coupon bearing bond, and then let's send it to in the middle. Okay, suppose we have data looks like this. Okay, then what we have to do is, so this is observed price. So it is observed. And then let's call this theoretical. Theoretical price. We can check theoretical collection of theoretical coupon bond prices are similarly now we can simply use the formula. Actually, I can copy this formula over here and then change it slightly. for the theoretical value is now, let's call hat over here. And then because it is J, J, and then, how can I put now J, okay? Now we have theoretical bond price. This is not pretty. I want to make it prettier. Head, okay. Okay, slightly better. Okay, so we have a head over here. So this theoretical, of course, here, of course, we do not know Z0T yet, which 0T is, okay, we don't know this one, which we have to estimate. Then the question is how to do that, okay? Do you have any idea? Do you have any suggestion? So our goal is we have this data, okay? We have this data. And then our question is, our goal is to find this one, okay? And then how to do it? Do you have any suggestion? Any student? Any student? Suggestion? Kim Ye-chan, any suggestion how to do that?
잘 모르겠습니다.
네, 최윤영, any suggestion?
잘 모르겠습니다.
네, okay. This is actually very simple. So simple. So what we have to do is, okay, we can minimize the distance between observed and theoretical price. So we want to find the Z, series of Z, then minimize the distance between theoretical and observed price. Okay, so that's our goal. So what we have to do is, minimize. Minimize what? We have to minimize sum of squared distance between observed and statistical parameters. So sum, again, this is a J to the power of n. We have n, right? Yes, we have n number of data. Okay, J equal to 1 to n. Okay, minimize what? We have to minimize the distance between the two. So distance, 제곱, square between distance. Okay, we have to say distance bj 0 minus bj 0, and then we have a head over here. Okay, so we have to minimize that one. Okay, so this makes sense, right? So we want to minimize that. Okay, minimize it by changing z. Okay, so we want to find a series of z, then minimize this one. Okay, so our goal is okay. Our goal is identify, right? We want to identify z. This is something we want to find. Identify z for what? For 0, and then identify this one. Okay, for text elect for and then over here, and then for 0 less than equal to, okay, 0 less than equal to t, right? So we have a subsequent t over z, and then less than equal to max, right? Max t. Wait. There should be a yeah, small t is the big T. I think this is the one for 0 greater than 0 and big T. Okay, so this makes sense, right? So yes. So our goal is again, now we observe only BJ, observe the coupon board price. So we theoretically construct by combining a 0 coupon board, which we don't know yet. And we have to combine that. And then construct the theoretical price. And then we measure the distance and just run your Python code or other computer code to minimize this one. Of course, in the initial period, you have to start from some random number of z, but computer will find the solution from that random number to the real z. Okay. So any question? Does it make sense? And in that process,
Professor, I have a question for the class.
Oh, yes.
Okay. I just wondered whether because zero coupon bond does not have any interest, its price volatility is bigger than normal corporate bonds, or is it same?
Well, we cannot say that. It depends on situation, of course. You mean coupon bearing bond and zero coupon bond, which are more volatile? That is your question, right?
Yes.
That depends on timing of cash flows. Right? It depends on which cash flows are volatile and whether that is included in coupon bearing bond or not. But if we extract zero coupon price of the zero coupon bond out of observed coupon bonds, then there is the volatility should be consistent with each other, right? Because they exactly include the same information. Not exactly, but almost, right? If number of the bonds, number of coupon bearing bonds and length of t are exactly same, then we have an equation, we have a t equation and t unknown. In that case, we have an exact solution. So in this case, in order to work this one, we should have, in order to solve this minimization problem, we should have data observable bond more than t. So let me write down because this is important. In order to implement this in order to solve this minimization problem, we expect what? Nt, which should be greater. We expect n is greater than t. Okay. In that case, we have more data than the unknowns. So it is called a regression problem. So basically, it is a regression problem. We are regressing. What we are doing is basically we are regressing observable bond price into series of cash flow. So practically, we solve the problem with linear regression. Okay. For the regression, it is not econometrics class, so I will not cover linear regression. Any other question? So in order to do this, you need to run optimization. If you do the regression, that is fine, but more generally, you have to run some optimization problem. And then in Python, there is a good optimizer, this one. So Python simple optimizer, if you click this one, there are Python code to the minimization for some arbitrary function, for some non-arbitrary function, it is scientific function, for a function called the login, it finds the minimum value of this login function. Okay, so this is very good. So you can practice this one. Next, okay, let's do some Python. I know many of you don't have any experience in Python, but that's fine. I'll go over step by step. So let me stop the recording for the time being.